Peter, how does Git work? How can it store all the versions of my project without taking up massive amounts of space?
Let's start with the essentials, Stewie. When you run git init, it creates a hidden.git folder that contains your entire version control database that, among other things, has an objects directory where Git stores all your files.
What do you mean by objects?
Git stores every file in your project as a blob object with a unique ID hash based on the file's contents. So if you have 10 files, that's 10 blobs in the objects folder, each compressed and named by its hash.
So each file becomes a blob, but how does Git know which blobs belong to which version of my project?
That's where commits come in. A commit is a small object that contains metadata like author, timestamp, message, and most importantly, a reference to a tree object. The tree is like a directory listing that, instead of holding files, holds the IDs of their Git objects.
So when I make a new commit with some changes, what actually happens?
Git creates blobs only for files that changed, then creates a new tree object with references to all the blobs for that version, mixing new blobs with existing ones for unchanged files. The commit object then points to this tree, giving you a complete snapshot.
But wouldn't storing all these blobs still take up enormous amounts of space over time?
Here's the clever part. If a file hasn't changed, its content produces the same hash, so Git reuses the existing blob. If you have the same README file in 100 commits, it's stored as one blob that 100 different trees reference.
So when I check out an old commit, Git reconstructs my project from these blobs?
Exactly. When you check out an old commit, Git reads that commits tree, finds all the blob IDs it references, and shows you only those files. It's that simple.
That's genius! Such an elegant solution to a complex problem.
Genius and surprisingly simple. Millions of developers use Git every day, but it only took Linus Torvalds a few weeks to create the initial version, proving that the best solutions are often the simplest ones.